Hi, good evening. Hello, guys. Suti. Hi. From which school you are? Am I audible, right? Let me know. I'm going to launch on poll. Yes. Guys, am I audible, right? Let me know through the chat box once. Today is my voice is properly audible, right? For everyone. Yeah, thank you so much. Actually, I got few suggestions. Actually, so many of you are actually saying that my voice is not audible to up to the mark. So what I changed my device today. So is there any effective voice will be available means just due to the changing of my device. That's it. Okay. Yeah, sure. We'll start our session within 2 to 3 minutes. Okay. Let them to join everyone. Cool. And how is everything going on in our school? In your schools, 12th syllabus is it started or not? May I know? Right. Right. Everything is perfect. And please do participate in a chat box. Meanwhile, when I'm teaching, when duration, if I ask any question means try to pass the answer in a chat box. Cool. And meanwhile, if you are getting any doubt means that time also you can drop your doubts in a chat box. I will try my level best to clear your all doubts. Okay. एक बार चेक करता हूँ यार यूट्यूब में क्या हो गया हालत you can drop your doubts in a chat box. I will try my level best to clear your all doubts. Okay. Today I got it. Yes. My device is problem. Yes. 100%. Okay, चलो start करते हैं आज का class. In this class, guys, we are studying about two more new concepts. First one is that gravitational field strength due to a hollow sphere. लिख दो. Okay, we are going to study today gravitational field strength field strength due to hollow sphere. Hollow sphere, pehla. Okay, and next we are going to study the same thing, gravitational field strength due to solid sphere. Solid sphere में कैसा होता है gravitational field strength, and then after next will be acceleration due to gravity. Up to today, while doing some calculation, we took the value of g is equal to 9.8 meter per second square. No, how it will come? What is the relation for the g in this gravitation chapter? Everything we are going to study today. Okay, this is called the acceleration due to gravity. Acceleration due to gravity. And one more point also you might know, guys, what is that? This g value, the value of g will not same every point on the earth. In case if you're going deep inside the earth, and if you're going above the surface of the earth level, means the value here, this one 9.8 meter per second square, it will not be constant, right? It will be changing. Okay, how it will be changes? That is the concept, nothing but variation of g. Okay, these are all the main four concepts which I took today, and from today onwards we'll go little faster. Okay, definitely, because what are the things which are required for you all, guys? Basic things, I told everything. Okay, those are the basic things. Definitely what we are discussed in past four lecture. Okay, the same thing will be appear in electrostatics, right? Electrostatics में same concept आता है, same problem कुछ किया था ना मैंने, that is also same, right? Okay, guys, those who are joined now, okay, within 1 minute in this time period, guys, please let me know through the chat box. Am I audible right today? Is my voice is perfectly audible right for everyone? Do drop your response in a chat box. Yes, that's great. Yeah. Okay, these are the concepts which we are going to study today. And moreover, before starting the concept, let us go to a quick recall what we studied in a previous class, right? Previous class we studied one important topic. Due to the mass distribution, some point where we are considering, at that point what will be the gravitational field strength we need to find out, correct now? That's why I took this arc shape ka ek mass with some having length, is there kya liya tha? Basically mass and radius r. इसके वजह से at this point p के ऊपर कितना gravitational field strength था, right? We calculated by deriving one equation. We got the equation, लिख दो, g is equal to इधर ही है g m divided by r square phi into 2 sin pi by 2, correct now? By using this equation, we find out the gravitational field strength for a various objects. Like if I'm going to take the arc of means semicircle, अच्छा से नहीं आया, adjust कर लो. Okay, क्या है semicircle? In this semicircle, where I find out gravitational field strength at the midpoint, x point में, correct ना? X point में with radius r, ये पूरा का पूरा mass m, correct ना? How to find out? Simple सा equation है ना हमारा पास, gravitational field strength E is equal to g m divided by r square phi 2 sin phi by 2. Use this equation, we will get the answer. How much we will get? Yesterday I solved, no? R square, right? Yes, R square itself. Okay, answer कितना आता है इसको? I'm writing here, देखो, E is equal to, it will be vary from 0 to 180 degree. 180 is nothing but pi, correct now? Yes, we need to change the value here of pi, that's it. G m divided by r square pi, here 2 sin of pi value, it is nothing but phi divided by 2. Sin phi by 2, it is nothing but sin 90. Value will become 1. 1 into 2, 1 hota hai. Then gravitational field strength at the midpoint for a semicircular ring will come out to be 2 gm divided by r square pi. Clear? And moreover, yesterday I told one more point also. if I'm going to take, what if I'm going to take quarter of a ring? We solve this one also. Just I'm क्या remember, I'm remembering this point. Okay, at this point x के ऊपर calculate करना है. क्या calculate करना है? Gravitational field strength. From where to where it is varying? From 0 to this is pi by 2. Here also you need to find out the gravitational field strength, means use this equation. Equation क्या है? By head कर लो, कोई problem है. E is equal to gm divided by r square phi into 2 sin pi by 2. करेक्ट ना? यार phi का वैल्यू कितना रखना है? pi by 2 रखना है, right? If you put pi by 2 here, means it will become pi by 4. Sin pi by 4 means 1 by root 2. Correct na? Either it will become 1 by root 2. Substitute that equation here. E is equal to gm divided by r square. इधर क्या है? phi value pi by 2 into 2 by root 2. Right? Solve this one. You will get an answer around gm 2 root 2 divided by pi r square. This is what the answer for a quarter of a ring. Right? We solve this one right now. Let me know last class is understood to everyone, right? Chat box में थोड़ा बता दिए, बता दो. Chat box से ले ली स्वल्पा. I will get some boost. Right? Amazing, amazing. Right. Cool. Okay, today we'll start a new concept, that is gravitational field due to hollow sphere. एक hollow sphere है. Hollow means काली sphere. Correct ना? काली sphere. Meanwhile, उसका circumference है ना, उधर mass uniformly distribute होता है. इधर mass है ना, this mass is uniformly distributed around the circumference. Inside empty, outside भी space empty होता है. Correct ना? This is called the gravitational field strength. इधर क्या हो रहा है मेरा लैपटॉप? ओके, पहले हॉलो स्फीयर देखते हैं, बाद में सॉलिड स्फीयर देखते हैं. एक पहले आई वांट टू नो, जस्ट रिमेंबर व्हाट वी एक्चुअली टॉट यू, व्हाट आई टॉट यू एक्चुअली. मान लो इधर एक मास है, इसका मास m. At this point, if I want to find out the gravitational field intensity at this point, point कितना दूर में है? r distance में. सुनो, ध्यान से सुनो. What will be the gravitational field intensity at this point? We took here gm by r square. Gm by r square. Keep this point in your mind. Here always E value is inversely proportional to the r square. E is inversely proportional to r square. Correct na? Similar way, what I want to do here is this one. Yeah. सुनो इधर, इसका मास है m, right? ये hollow sphere का सेंटर है ना, सेंटर से here तक the distance will be r. Here तक the distance will be r. Now we need to find out the same thing. Gravitational field strength को find out करना है. किधर? First one outside of the sphere के बाहर calculate करना है. Second, this is the first point. Second point on the sphere calculate करना है. किधर? On the circumference of the circle है ना, उसके ऊपर calculate करना है. Third one inside sphere calculate करना है. क्या calculate करना है? Gravitational field strength. ठीक है ना? These are the things which we need to calculate in this particular topic. Right? Cool. Now, मान लो, just think, this is the point where I'm considering outside this sphere. क्या है? Outside this sphere है. Up to this point, the distance will be, I'm going to take this distance as an r. R is the distance between center to the point P. Guys, I want to know one question here. I want to know one answer from you guys here. If it is hollow sphere, means this is an hollow sphere, may I know where the whole mass of this hollow sphere is concentrated? चार्ट बॉक्स में बोल दो, where the whole mass of a hollow sphere is concentrated. I'm waiting for your answers. Meanwhile, Ballari, Chitradurga, Kripa, and then who are there? Only 4 members today. Okay, cool, no problem. Center, exactly. At this center only, the whole mass is concentrated. Correct now? Meanwhile, I can say the mass will be present here. From the mass to the point, we need to take the distance. No, hence gravitational field intensity outside the sphere. First, क्या होता है इधर? E is equal to G M. M means mass of this hollow sphere divided by R square. R square is the separation distance of that point P from the center of the mass. I told you, while taking gravitational field strength or gravitational force, we need to take the distance from the center, because it's a center la, no, center to center we need to take, right? What I'm saying, that's why this is the gravitational field strength outside the sphere. ये क्या है? outside the sphere के लिए है. Clear? लिख दो. This is for outside of sphere. Outside of sphere. And देखो इधर E value again it is inversely proportional to R square. देखो इधर E value है ना, it is inversely proportional to R square है. Means if this distance R है, if I'm going to increase the distance by 2R, R का value I'm going to increase this by 2R. If I'm increasing the 2R means इधर क्या होता है देखो, E value is proportional to 1 by 2R square, sorry 4R square होता है, square करने के लिए. Means if it is increased means the value of gravitational field strength decreases, right? Inversely proportional का relation ऐसे होता है ना, R value increases means E value decreases. कितना decrease होता है? It is depending upon the distance, how much you are going to far away from the original point. If I am going to increase the distance by 2R, ये R है ना, M to P. If I am increase that one to M to P, 2R distance means ये point में इतना intensity था ना, उसका 4 times intensity will be decreases at this point. कितना point में? ये P dash point में 4 times decrease होता है. We'll write here, this is EG means at this point it will become EG by 4 times. Clear? Think karo. And meanwhile, if you are getting any doubt, please drop your doubts in a chat box. Okay, we'll move to the next point. Next point क्या है? This is the first point. हो गया, खत्म कहानी. Okay, next point क्या है? On the surface. मान लो I'm going to bring this point P towards the hollow sphere. I'm going to keep the point P here. Point P now here. Okay, what is the distance from the point P to mass concentrated there? It is again R only. Separation distance always we need to take R else X. Okay, now what will be the equation for this one? At this point, I'm going to call this one as a P1. This is P2. Okay, P2 में gravitational field intensity कितना है? Again the formula Gm divided by R square. Correct है. But इधर देखो, थोड़ा geometry देखो, R value will be equal to radius of the earth. R value is equal to radius of the earth na. That's why here gravitational field strength will be equal to Gm divided by R square. Clear? May I know in a chat box? Is it clear, right? For everyone? Yes. Good guys. देखो, I will conclude one point here. Next slide में क्या है? Okay, good, no problem. 2 points we discussed. पहला point था center of mass इधर था, R distance में P point था, इसके वजह से at this point gravitational field strength आ गया gm divided by r square. Always E is inversely proportional to r square here. Okay, and hence if I'm going to bring this point P near the on the surface means it will comes to the circumference. Circumference का distance कितना होता है इधर from the center of the circle r होता है. At this point P2, this is a P1. P2 के ऊपर gravitational field intensity E2 if I'm going to call means it is equal to gm divided by capital R square. खत्म कहानी. Okay, what if I'm going to take the value of P or the point P position inside the sphere? Now the point P will be here, P3. At a distance again R. May I know the answer for this question? At this point P, now the point P is located inside the sphere. कहाँ locate हो गया है? Sphere के अंदर है. At this exact point P, what will be the gravitational potential? E3 का value क्या है? I'm expecting this answer from your end. Simple है. देखो भाई थोड़ा. Who will give the first answer? I'm eagerly waiting for the answer from your end. Hello, are you there or not? Gm by r square. Yes. But wrong hai. Wrong. Why it is wrong means actually yesterday class में मैंने बोला था तो आपको क्या बोला था? This is actually the mass which is segregated all over the circumference. Correct ना? Circumference में mass है. Mass किधर है? Circumference में है. Okay. Inside if you're going to take at any point, the value of this value will become 0. कितना होता है? 0 होता है field intensity. Yes, field intensity 0 होता है. If I'm going to take in the center, mid of the center you take 0 होता है. Okay, or else you may take like this also. At this point from the center r distance you may take here point P. इधर भी 0 होता है. इधर take here also 0. Wherever the point you go, the value will become 0 only. Okay, if you want to understand this one, no, just then go through previous class videos, or else just go through the things which you written. Okay, apply there. What we took here? Small masses and their separation distance. Correct now? Either separation distance very small. If I'm going to take the symmetry of the mass downward means either separation distance is large. Correct? Due to the change in position distance all over the point inside the sphere, the value of intensity of gravitation will become 0. Clear? Hope it is clear, right? We'll go through one graph. That's fine. Okay, लिख दो 0 है. That's it. कुछ नहीं. Okay. And then if you want explanation means please drop your doubt. I will give the exact explanation also. Okay, इधर देखो. We got 3 equation for a hollow sphere. क्या था? First equation था E is equal to gm divided by r square. This is for outside. Correct now? This graph is very important for 12th standard electrostatics also. Second point था on the sphere we got gm by r square. This is on sphere. And third point था 0. Okay, देखो इधर. This is the hollow sphere. Figure देखो. उसका रेडियस कितना है? इधर से इधर तक r है. Okay, here the graph will be, I'm going to plot the graph along y-axis. Along this y-axis, I'm going to take the gravitational field strength. Along the x-axis, I will take position, where the position is there. We guys know that इधर ग्राफ देखो, सेंटर में ग्रेविटेशनल फील्ड इंटेंसिटी कितना मिला था हमको? 0 मिला था. एज अ डिस्टेंस ये पॉइंट लेता है P1 at a distance R1 if I'm going to take means okay इधर भी वैल्यू 0 था. if I'm going to take here to here it is R, the value becomes 0. करेक्ट ना? up to the radius हमको 0 मिला था value inside this sphere. when we on this surface at a distance of R we got maximum value of field intensity. maximum मिला, right? And then after from this point onwards, if I'm going to go further away, the value will be start to decrease square of their distance. Correct na? This is what we need to plot. देखो इधर at the origin point, as I move R को बढ़ा रहा हूं, intensity will be 0. R further I increase, intensity is 0. R I further increase at the point of किधर रेडियस को इक्वेट होता है ना, अप टू दैट पॉइंट. एट दिस पॉइंट आर वैल्यू इज इक्वल टू रेडियस. एट दिस एग्जैक्ट पॉइंट तक 0 था क्या? ये फील्ड इंटेंसिटी. एट दिस एग्जैक्ट पॉइंट इट हैज अ मैक्सिमम वैल्यू लाइक दिस. इट हैज अ मैक्सिमम वैल्यू, राइट? फर्दर इफ यू गो फर्दर मींस द ई वैल्यू कैसे रिलेट होता है? 1/r², डिक्रीज होता जाता है. करेक्ट ना? डिक्रीज करने का तरीका ऐसे होता है. फर्दर ऑन इंक्रीजिंग द डिस्टेंस इन दिस डायरेक्शन द वैल्यू ऑफ इंटेंसिटी विल बिकम 0. दिस इज कॉल्ड द E proportional to r². okay, this is the graph plotted here, intensity versus distance. Clear, right? Let me know in a chat box. Is it clear? Sir, why you took like this exponentially decreasing curve? We can take straight line also, no? You have that question in your mind. Actually आपको मैथ्स में पढ़ाता है. मैथ्स में क्या पढ़ाता है? y is equal to 4ax², पैराबोला का इक्वेशन. ये 4a का काम नहीं है हमारे पास इधर फिजिक्स में. Now y is equal to, if I am going to take x² means it's a parabolic equation. How it will become parabola? पैराबोला कैसे आता है? देखो इधर ये है y, this is x². x² का मतलब x है, x² का मतलब 2 पॉइंट्स आता है x के लिए. करेक्ट ना? एक +x, एक -x. इधर स्ट्रक्चर कैसे आता है? सिंपल है. किधर सिंगल पावर है? देखो इन दिस इक्वेशन, देखो ये इक्वेशन में किधर सिंगल पावर है? इन विच पार्ट सिंगल पावर है, उसके तरफ एक ग्राफ को ओपन करना है लाइक दिस. y के तरफ सिंगल पावर है ना, इसके तरफ ऐसे ओपन करना है. Similarly, I followed for this one also here. E is proportional to 1/r². It is nothing but 1/r² only. इधर देखो E which direction we took? Y axis. 1/r² we took in a x axis. ठीक है ना? But you may ask, sir, where is the remaining part here? Actually, after reaching a infinity, the value of intensity will not increase. That's why we took only half of the portion up to this point. This portion will not come for this particular case. Clear? Clear, right? बहुत बोल दिया मैंने. टाइम जा रहा है. Anyhow, whatever I would like to present here, no, it should be productive for all of you people who are watching my class. That is my ultimate thing. Clear है ना? Okay, next slide चलते हैं. This is the case of solid sphere. ये क्या है? Solid sphere है. Similar way, कोई प्रॉब्लम नहीं, सिंपल से है. A solid sphere means पूरा का पूरा मास है इसके अंदर. मास कितना है? m है. इसका रेडियस फ्रॉम दिस पॉइंट इज r. Okay. Now also here also in this case also we need to study 3 cases. We need to study 3 cases. First one will be outside. Quickly लिख दो. Second one on the surface. On the surface. Third point will be inside. This is very important. Inside. पहला point outside the sphere means ये रहता ना. Outside the sphere के लिए distance कितना होता है from the center? r होता है. This is the point P. Okay. At a distance r means electric field strength कितना होता है? Again gm divided by r square. Guys, देखो, this is the equation. At this point, if you are going to keep on small mass m also, m के वजह से एक ग्रेविटेशनल फील्ड स्ट्रेंथ चेंज नहीं होता है. m के वजह से, स्मॉल m के वजह से ग्रेविटेशनल फील्ड स्ट्रेंथ चेंज नहीं होता है, बिकॉज स्मॉल m doesn't produce any gravitational field, because we are considering only capital mass as a source mass. Small is a test mass, है ना, इसलिए कोई प्रॉब्लम नहीं. नेक्स्ट, एक हो गया. सेकेंड पॉइंट क्या है? इफ आई एम ब्रिंगिंग दिस पॉइंट टुवर्ड्स द सरफेस, इफ आई एम गोइंग टू कंसीडरिंग दिस वन ऑन द सरफेस, P2 ऑन द सरफेस, एट दिस कंडीशन E G का वैल्यू, और सेकेंड पॉइंट में क्या होता है? अगेन GM डिवाइडेड बाय R स्क्वायर, but here R square value will become equal to radius. Then this value will be GM by R square. Right? Clear now? This is the first point. This is the second point. Clear? Okay. What will be the third point? Okay, if I'm going to take the value of point P at this point, at a distance R, P3 पर, what will be the gravitational field intensity? बता दो मुझे. Tell me. What will be the gravitational field intensity at this point? Point P3 के ऊपर gravitational field intensity कितना होता है? I'm expecting the answer quickly. मैंने बोलता हूँ zero नहीं होता है. Zero will not possible here. Why? Question will be arise like that. Why? I will tell you. Okay, this is one of the special case, guys. Special case क्या है? देखो इधर. Already I took this one. Yeah. देखो. This is a sphere of radius r था. Okay. If I'm going to take the point P at this position at a distance of r from the center, at a distance r from the center, the whole mass will be same here only. ये P के ऊपर, actually P is not in a hollow place, not in a open mass place. P ಅನ್ನೋದು hollow sphere ಒಳಗೂ ಇಲ್ಲ. What I'm saying, understand, right? ಮತ್ತೆ mass ಇಂದ ಆಚೆನೂ ಇಲ್ಲ. It will not outside of the mass. Okay, P is lies. Right. Great work, great effort. We'll calculate this one. Okay. देखो इधर क्या होता है. देखो, मान लो ये क्या है यार. हाँ, मान लो now P is at this position. कितना डिस्टेंस में है? R distance. Okay. If I am going to segregate this whole mass into two parts, at this point is P on the surface, or else you might be think like that it is inside here. Okay. Now just imagine this case we studied like a hollow sphere. Correct ना? Hollow sphere के जैसे दिख रहा है. Inside कुछ भी नहीं है. इधर कुछ भी नहीं है. Nothing is there here. Nothing is there here. Correct ना? Then nothing is there means if I am going to consider external world at this point, इसके अंदर the value of G will become 0. The value of G becomes zero. मानते हैं ना? Okay. Means outside this sphere से ये portion है ना, ये portion वाला yellow color, इसके वजह से at this point the value of gravitational intensity will be 0. That's it. Okay. Next point क्या है? Inside. Now देखो, inside वाला only I'm taking inside वाला. When I'm taking inside, this is a center at a distance r. No, we took the point P is here. On the surface. Now for this case, the intensity will become Gm by R square. Correct now? Gm by R square. So many of you are stopping the equation here only, but the thing क्या है ना इधर? Thing क्या है? Either mass is not same. when I'm going to take the total mass the capital M इतना था, but when I'm going to take here at this particular case इतना मास, एक ग्रीन कलर कर दिया था ना मैंने, ग्रीन एंड व्हाइट हो गया नो, देखो इधर इतना मास नहीं है, करेक्ट, दैट्स व्हाई ओनली मास इज डिफरेंस हियर, मींस इधर m डैश लिखते हैं मैंने, mass is not exactly same what before it is, only this much of mass which I'm taking here radius r, no, this much of mass only contribute the gravitational field strength, not from the outer shell. Now clear? If you know up to this point means then it is good and enough. We'll continue this part now. Call equation number 1. ओके ये मास को फाइंड आउट करना है, कितना है मास को फाइंड आउट करना बहुत इजी है, कैसे है, एक्चुअली एक स्फीयर है मींस इसका पास वॉल्यूम भी है, डेंसिटी भी होता है, इफ आई एम गोइंग टू टेक दिस मच ऑफ पोर्शन मींस इसका डेंसिटी कितना होता है ना, डेंसिटी कितना होता है, होल स्फीयर का डेंसिटी भी सेम ही होता है, राइट, डेंसिटी विल बी सेम फॉर अ सेम मटेरियल, अंडरस्टूड राइट दिस पॉइंट। मान लो यार, देखो इधर वाटर है, इसके अंदर वाटर का डेंसिटी कितना है, वाटर डेंसिटी 1000 kg पर मीटर क्यूब, नो 1000 kg पर मीटर मींस 1 मीटर क्यूब में 1000 kg फिल होता है। इफ आई एम गोइंग टू टेक ओनली 1 ड्रॉप आउटसाइड मींस ये 1 ड्रॉप होता है ना, 1 ड्रॉप का डेंसिटी भी सेम ही होता है 1000 kg पर मीटर क्यूब, मींस वो ड्रॉप को ऐसा ड्रॉप को इफ यू आर गोइंग टू पुट इनसाइड द 1 स्क्वायर क्यूबिक मीटर मींस सेम वैल्यू आता है, दैट्स इट, कोई चिंता मत करो इसमें, डेंसिटी विल बी सेम, दैट्स इट। ओके, meanwhile if you getting doubt means drop your doubts in a chat box, I will solve, that is what I am saying. Okay, come to the point, total density क्या होता है, ये total density है, okay, total density will be density is equal to mass by volume, mass original mass m था, volume कितना था 4/3 pi r cube, this is the original one, r cube radius पूरा था ना, इसका था फर्स्ट केस। नाउ सेकंड केस में, इन दिस केस में क्या हो गया, डेंसिटी डिक्रीजेस, कितना डिक्रीज, सॉरी डेंसिटी नॉट, मास डिक्रीजेस, राइट, मास वी नीड टू फाइंड आउट, दैट्स व्हाई रो इज इक्वल टू m डैश बाय v, करेक्ट ना, m डैश कितना है फाइंड आउट करना है, दैट्स व्हाई m डैश डिवाइडेड बाय v कितना होता है 4/3 पाई, r के प्लेस में स्मॉल r क्यूब होता है, खेल खत्म, नाटक बंद, सब्स्टिट्यूट, नाउ वी नीड टू फाइंड आउट दिस m dash, then take 4/3 r cube right hand side, then it will become 4/3 pi r cube, we need to multiply to rho is equal to m dash, ठीक है ना, m dash वैल्यू आ गया। now substitute this value m dash in this equation number 1, equation number 1 को substitute करो, इधर substitute करता हूं, देखो E is equal to g, m dash means 4/3 pi r cube रो, करेक्ट है ना, डिवाइडेड बाय r स्क्वायर है, राइट, व्हाट आई एम सेइंग, देखो इधर r स्क्वायर से r क्यूब में 2 स्क्वायर फिनिश, मर गया, इक्वल टू 4/3 g pi rho r, g pi rho r, guys note down this equation, ये equation important होता है, I'm saying this is one of the important equation, दो equation आता है बोल दिया था मैंने, this is also one of the important equation, क्यों, इधर 4/3 देखो, this is constant, g constant, pi constant, density of that particular object also constant होता है, then ये value r के लिए proportional होता है, ये वैल्यू r के लिए क्या होता है, प्रोपोर्शनल होता है। I will tell you one thing, it's an amazing thing, okay, you will definitely realize this one, okay, first you note down this one, E is proportional to your r square, in which case especially in solid sphere में field strength proportional to r, ठीक है, right, good to go. And then I told you one more thing also, one more point I told you, this density है ना, this density will be same for a small sphere और a बड़ा sphere, कोई प्रॉब्लम नहीं. डेंसिटी का इक्वेशन क्या आता है, देखो इधर पहला इक्वेशन इधर लिख दिया था मैंने डेंसिटी का, राइट. डेंसिटी का इक्वेशन लिख दिया था ना मैंने इधर, इसको उधर सब्स्टिट्यूट करो. आई एम गोइंग टू कॉल दिस इक्वेशन नंबर 2. ओके, सब्स्टिट्यूट डेंसिटी इक्वेशन हियर, लिख दो. ओके, लिख दो, आता है, सब कुछ आता है, कोई प्रॉब्लम नहीं. नेक्स्ट पेज में करता हूं मैंने. ओके, नेक्स्ट पेज हियर, हियर इट इज. ओके, हमको मिला था E इज इक्वल टू 4/3, क्या मिला था भूल गया मैंने, 4/3 G pi rho r, G pi rho r. Shit. G pi rho r, correct ना? That's good. Okay, then rho का वैल्यू क्या बोला मैंने, मास, टोटल मास है, कोई प्रॉब्लम नहीं, बाई वॉल्यूम, वॉल्यूम तो 4/3 पाई r क्यूब है, r cube. Substitute that one here. Then this E value will become, देखो 4/3 G pi, rho means rho mass divided by 4/3 pi capital R cube, ऊपर क्या है, R है. This 4/3 मर गया, this pi cancel, remaining thing क्या है, देखो E is equal to mr divided by, इधर g है, भूल गया मैंने, g by r cube. This is the gravitational field strength inside this sphere. This is the equation for gravitational field strength inside this sphere. इधर भी देखो, the value of Eg is proportional to r. r के लिए proportional है. And don't take capital R. Don't take capital R. Capital R will not change for a given sphere. ಕೊಟ್ಟಿರೋ sphere ಗೆ capital R change ಆಗಲ್ಲ. Correct what I am saying? Only the thing is changing position R. R X ಅಂತ ತಗೊಂತೀವಲ್ವಾ, that will be changing, not capital R. Clear na? Is it understood right up to this point? Let me know through the chat box quickly. This is very important equation. At this point P, if I'm going to find out from the center means, okay, at a distance R, the value will become this much. Let me know in a chat box. Amazing, amazing. Gm by a cube, हाँ, a cube r तो डिनोमीटर हो गया ना यार, आंसर किया था आप, थोड़ा सा गलत है इधर, वो r ऊपर आता है, r ऊपर आता है, ठीक है ना. And then one more point, remember always gravitational field strength value gm r divided by r cube है ना, इधर डायरेक्शन किधर आता है, always towards the mass. If you put negative sign also it is correct. If you put negative sign also it is correct. How sir? देखो इधर मास इधर है, a पॉइंट के ऊपर और मास के ऊपर फील्ड स्ट्रेंथ बताना है, at a distance of r from the capital mass m, we will take r from the capital mass means r distance में है point from the capital mass, we'll say in this direction r तो e direction में है, force किधर लगता है, force in the direction में लगता है. Similarly the strength of the field will be also in a same direction. Clear right? That's why if you put a negative sign here also there is no problem. Clear? Hope it is clear, right? Let me know in a chat box. Good, that's good, great. Okay, we'll understand one graph basically based on this topic. Okay, graph के पहले we'll write the things which we derived here. Okay, first one, outside the sphere क्या आया था, for outside the sphere solid sphere के लिए gravitational field strength g m divided by r square आया था. And then on the surface के ऊपर कितना आया था, gravitational field strength will be g m divided by r square, similar to the hollow sphere. And then inside इनसाइड का कहानी थोड़ा चेंज हो गया, राइट? इनसाइड क्या हो गया, Eg वैल्यू विल बी इक्वल टू gm r डिवाइडेड बाय r क्यूब हो गया. ओके, हियर इन ए केस में r स्क्वायर इनवर्सली प्रोपोर्शनल, सेकंड केस में इनवर्सली प्रोपोर्शनल टू r स्क्वायर ओनली, दैट इज r only. Here in second also r value will be equal to r only, and in third case here E is proportional to r. Here in these two cases it is inversely proportional, third case में directly proportional होता है. ठीक है ना? Similar way we will plot it, will plot. Okay, come to the point of center. Center से at a distance r तक. Okay, from point P1, this is a point P1. If I'm going to come to this point means क्या होता है वैल्यू, देखो सेंटर से अप टू हियर तक, इनसाइड सॉलिड स्फीयर द वैल्यू ऑफ E is proportional to r. E is proportional to r means r value increase करते हैं ना, field strength also increases. That's great. Field strength also increases. Correct ना? That's why y axis में E लेता हूं मैंने, क्या बने, x axis में r लेता हूं. Similar way, if I'm going to increase the r value, E value also increases. Further increasing r value, E value also increases. Further increasing r value, E value increases up to what point? Up to the point of r value is equal to capital R, means radius तक, up to this point. Up to this point. कैसे increase होता है? Linearly it is increasing like this. Right now, this is the maximum point, right? This is the maximum point. E is directly proportional to r here, and further after reaching here, it is inverse. This is the first point. Second point, E is inversely proportional to r square. Again, it will be, how it will be decreases? Exponentially, it is decreasing like this. Clear है ना? This is exponentially decreasing term. क्या हो गया मुझे? लिख दो इसको. दिस इज वेरी इंपॉर्टेंट ग्राफ. और एक कहानी है आज. विल रन. होप इट इज अंडरस्टूड राइट फॉर एवरीवन. फॉर एवरीवन इट इज अंडरस्टूड राइट. Try to pass a message in a chat box. Srushti, Krishna, Chitradurga, Ballari. Great. Okay, next concept है. हाँ, मान लो इधर क्या है. हाँ. Okay, good. Okay, good. देखो इधर एक मास है, कैपिटल मास है, स्मॉल मास m है. मान लो कैपिटल मास एक प्लैनेट है, स्मॉल मास सैटेलाइट है, which is revolving around the planet. Correct? When it is revolving, इसका linear velocity तो इधर होता है. This is the radius. Guys, when it is revolving, always towards the center, there is a force will be exist. What kind of force that is? Force exists towards the center. What kind of force that one? Centripetal force. Correct ना? याद है? Great. ಎಲ್ಲ ತುಂಬಾ great ನೀವೆಲ್ಲ. Centripetal force होता है. This centripetal force का equation बनता है, मैं लिखूंगा, कोई problem नहीं. m v square by r. A small m v square tangential velocity, r is the radius. You may take here capital R also, no problem. I will take here for a small while small r as an radius only, कोई problem नहीं. Okay, small r as an radius. Okay guys, do you know this centripetal force है ना? This centripetal force which is revolving a planet, revolving around the planet, a satellite which is revolving around the planet means इसके towards the center centripetal force आता है. This centripetal force where it is come from? this centripetal force actually it came from the gravitational force between the two objects. Gravitational force between a two objects से आता है. लिख दो इधर, centripetal force came from gravitational force. Gravitational force. Gravitational force आपको पता है क्या है, Fg is equal to Gm divided by r square. Actually, these two forces are equal. These two forces are equal. If I'm going to substitute that one now here, Fc is equal to Fg. Fc will become from the gravitational force and Fc is equal to Fg. Okay, substitute the values here. Mv square by r is equal to either G capital M small m by r square. R से इधर एक r मर गया, एक m से एक m चले गया, and then remaining thing here v square is equal to gm divided by r. क्या हो गया इधर, gm by r, करेक्ट है. v है ना, इधर स्क्वायर है. If I'm going to take this square right hand side means it will comes to under root. Then it will be v is equal to under root of gm divided by r. Guys, why I told this one? No, देखो इधर, any object which is revolving around the planet. Actually, however, we are going to discuss this one in a satellite. एक concept है, उधर discuss करते हैं मैंने. Okay. Actually, the velocity of the particle which is revolving around any planet which is producing the gravitational field. इधर mass है ना, एक gravitational field produce करता है. इसके वजह से any point like this planet a small mass which is revolving means उसका velocity कितना होता है, and velocity is how it is depending on the terms we need to know. That's why I took here. इधर देखो, this velocity, a छोटा mass का velocity, a छोटा mass का velocity doesn't depend on its mass. उसका mass के ऊपर डिपेंड ही नहीं है. देखो इधर इक्वेशन में कैपिटल M के ऊपर डिपेंड होता है, करेक्ट ना. देखो, velocity is directly proportional to mass of the planet which is producing the gravitational field. उसके ऊपर डिपेंड होता है, not on their own mass. And also velocity is inversely proportional to under root of r. r के ऊपर डिपेंड होता है. If r value will be increases means velocity decrease होता है. That's it. Just keep this in your mind and we'll move on. Okay. Clear है ना, ये दोनों पॉइंट लिख दो. क्यों, why I told this one? No, if your school teacher will start the electrostatic means they will move fastly, and then उधर एक concept आता है electron which is revolving around the nucleus. Okay, उसका velocity how it is depending upon their mass and how it is depending upon their distance from the center of the nucleus. The question will be appear for the CBSE board and as well as the NEET exam also. That's why I told in this point only. Clear है ना? Is it clear? बहुत बात करता है मैंने. Okay. Problem. Actually, this is a problem. Okay. Take this one for a homework. I will upload the notes by the evening to the drive. Okay. Take these notes and solve this problem. Okay, this problem is basically based on the velocity only. You need to find out velocity only. You need to find out. It's very simple. कोई problem नहीं, करो. Okay. हाँ, आता है next concept इधर, acceleration due to gravity. Okay, this is the actually concept which I need to take exactly 10 minutes back. 10 ನಿಮಿಷ ಇದೆ ನಾನು ತಗೊಂಡಿದ್ದೀನಿ. It's okay, no problem. Acceleration due to gravity क्या होता है? देखो इधर, सुनो, बहुत अच्छा है कहानी. Up to this point we thought like that this is an mass means source mass, especially this is a source mass which is producing the field, field को produce करता है. In this field any particle which is coming means उसका mass means a particle which experience the force which is produced by the बड़ा mass means सोर्स मास के वजह से कितना फील्ड प्रोड्यूस हो रहा है, उसके वजह से स्मॉल मास m फोर्स एक्सपीरियंस करता है. क्लियर है ना? वही कहानी इधर अडॉप्ट करना है, राइट? दिस फोर्स इज वैलिड थ्रूआउट द यूनिवर्स, ग्रेविटेशनल फोर्स, क्लियर? बट व्हेन यू कम अक्रॉस द प्लैनेट, पर्टिकुलर प्लैनेट, मान लो दिस अ प्लैनेट अर्थ, धरती माता है हमारा भूताई, हौदल्वा, ऑन दिस अर्थ इट हैज अ मास, मींस इसके मास के वजह से थोड़ा फील्ड रहता है, राइट? यस, वी कैन सॉल्व लाइक दैट आल्सो, कोई प्रॉब्लम नहीं, करेक्ट है, करेक्ट है, ओके, करेक्ट। इसका मास है यम, ये छोटा मास है ना, उसका मास है स्मॉल एम, ओके। ये मास के वजह से, ये छोटा मास के वजह से एक फोर्स एक्ट होता है डाउनवर्ड डायरेक्शन, करेक्ट? दिस इज अ छोटा मास यम, इसका वजह से डाउनवर्ड डायरेक्शन एक फोर्स एक्ट होता है ऑन द सरफेस टुवर्ड्स द सेंटर ऑफ द अर्थ। वी कॉल दिस वन एज एन वेट ऑफ एन ऑब्जेक्ट, दैट इज mg, mg होता है, कॉल इक्वेशन नंबर 1, mg होता है, क्लियर? सेकेंड, दिस इज द फर्स्ट फोर्स, क्या है? फोर्स है, वेट भी एक फोर्स, वेट भी एक फोर्स, वेट भी एक फोर्स, मन कीप इन योर माइंड, ओके। नेक्स्ट क्या है? ये बड़ा मास m है, ये छोटा मास स्मॉल m है, इन दोनों का डिस्टेंस कितना होता है? रेडियस ऑफ द अर्थ, रेडियस ऑफ द अर्थ होता है ना, मींस एक बिग मास के साथ छोटा मास है, ये दोनों को बीच में लिख दो इधर, between two masses, between m and m there is a force exist, there is a force exist, we call that one as an gravitational force, gravitational force, करेक्ट ना? ग्रेविटेशनल फोर्स कैसे लिखता है भाई? F इज इक्वल टू जी एम एम डिवाइडेड बाय सेपरेशन डिस्टेंस कितना है इधर? r स्क्वायर, स्मॉल r स्क्वायर था इधर, स्मॉल r is equal to capital R. Call this equation number 2. Actually, here these two masses, these two forces are equal. कैसे equal होता है? Equal होने के वजह से मास, छोटा मास है ना, on the surface of earth it is stable, or else if I'm going to sitting on the earth means like this, okay, I'm a stable means equilibrium position में means हम दोनों को बीच में एक फोर्स होता है ना, it will be equilibrium, means equal होता है, that's why, hence what I will do here, force of gravity is equal to W I will take from equation 1 and equation 2, okay, okay, few minutes we'll खत्म कर देंगे इसको, कोई प्रॉब्लम नहीं, ओके। एंड देन W क्या है? उल्टा लिख दो, कोई प्रॉब्लम नहीं। इधर Fg का वैल्यू क्या है? G कैपिटल M स्मॉल m डिवाइडेड बाय r स्क्वायर है, या W का वैल्यू क्या है? m इंटू जी है, इधर लिखा था मैंने, करेक्ट ना? दिस टू इक्वेशन, दिस आर द टू इक्वेशंस। नाउ देखो, स्मॉल m कट गया, देन रिमेनिंग थिंग विल बी G is equal to अंडर रूट ऑफ, सॉरी अंडर रूट क्यों आ गया इधर? क्या हो गया मुझे? G is equal to, वैसा है यार, G कैपिटल M डिवाइडेड बाय R स्क्वायर, करेक्ट ना? दिस इज द इक्वेशन we called acceleration due to gravity. This is no G is called acceleration due to gravity, okay, and you might be wondered, लिख दो इसको, बोलता हूं मैंने नेक्स्ट स्लाइड में बोलता हूं, लिख दो। एंड कैसा था क्लास? बोल दो चैट बॉक्स में, बोलो अंडरस्टैंडिंग हो रहा है ना सबको? सबको अंडरस्टैंड हो रहा है ना? क्लास कैसा है? नाइस, थैंक यू। गुड, ओके, नेक्स्ट देखते हैं, शॉर्टेज ऑफ टाइम, ओके, इधर ही लिखूंगा मैंने, कोई प्रॉब्लम नहीं। और किधर? इधर देखो, G वैल्यू क्या आ गया? G m डिवाइडेड बाय R स्क्वायर है, करेक्ट ना? इधर G स्टैंड्स फॉर universal gravitational constant 6.67 into 10 to the power of minus 11 Newton meter square per kg square, है ना? And then M stands for which planet you are taking. Actually we are living on the planet called Earth. Okay, Earth का mass कितना है? 2.5 into 10 to the power of 24 kg है. This is the Earth mass, 2.5 into 10 to the power of 24 kg. It is not exactly equal, almost nearestly. Okay, and R stands for here radius of the Earth. Radius of the Earth है 6,400 kilometers. 6,400 किलोमीटर. इस सारे के सारे values constant है, constant values. Okay, if you put all this value here, you will get the G value around 9.8 meter per second square. 9.8 meter per second square. Right? Right? Okay, this is all about guys today's class. आज का क्लास का टॉपिक था अब तक. Okay, meanwhile if you have any doubt means please drop your doubt in the chat box. Chat box में doubt को pass करो. I will clear your doubts. Actually I want to discuss today few more topics, that is how कहा गया, yes, how the acceleration due to gravity, this G value, how it will be vary on the above the surface, below the surface due to the variation of graph. Okay, however no problem, tomorrow कल करेंगे. Why I am saying this one? No, if we are built properly on this chapter means दो chapter मुफ्त में मिलता है 12th में. कौन कौन सा chapter? Electrostatics, field lines, electric potential. Okay, these two chapters will be understood very properly होता है. If those two chapters will be understood very properly means again fourth and fifth chapter आता है in a first term only, moving charges and magnetism, and then magnetism and matter. Those two chapters are exactly similar to the first two chapters. देखो एक चैप्टर पढ़ने के वजह से इधर 4 चैप्टर आता है. You have to concentrate only on current electricity is a big chapter, and then उसके बाद में 6th chapter आता है electromagnetic induction. Electromagnetic induction is a very simple chapter. Once if you understand means you never forget it. Okay, and later on AC current and then electromagnetic waves. Okay, कोई problem नहीं. 12th में when you come to 12th, no, teacher will teach you. Okay, okay guys, it's a good time with you all. We'll see you in tomorrow class. Okay, bye bye.